Hello everyone, welcome back to Math with Allison. Today we're working in our integration series, so we're going to be using trig substitution, specifically with the form x squared minus a squared. So let's go ahead and dive into it. When we see this in an integral, we're going to go ahead and use the substitution x equals a times secant of theta. So let's go ahead and set this up with a triangle so we can really understand why. So if I divide over this a, I get x divided by a is equal to secant of theta. And secant is hypotenuse, x divided by adjacent. So that means this remaining leg has to be x squared minus a squared, which is exactly why we use secant theta, is because we get this in our triangle. So let's go ahead and try an example. We have 1 over the square root of x squared minus 49, and x has to be greater than 7. So let's go ahead and see what we're working with. So this is x squared minus 7 squared, which tells us that a is equal to 7. So we're going to go ahead and use x is equal to 7 times secant theta. Let's go ahead and draw our triangle. So here we get hypotenuse is x, adjacent is 7, and then we get the square root of x squared minus 7 squared, or 49. So let's go ahead and think about this. We have our x, right? X is equal to 7 secant of theta. But in order to do a full replacement or substitution, we also have to replace our dx. So let's go ahead and solve for it. We're going to go ahead and use that x is equal to 7 secant of theta. And we're going to take the derivative of both sides in terms of x. So we get 1 is equal to 7 times, and that's going to be secant theta times tangent of theta. And now we need to multiply by the derivative of theta in terms of x. And this is how we get that dx. We're going to multiply it over. We get dx is equal to 7 secant theta tangent theta, d theta. And that right there is what we're going to use to replace it. So let's go ahead and rewrite our integral with all these different parts. We get 1 over the square root. First, we have quantity x squared, so I'm just going to square the whole thing right now. We get 49 secant squared of theta minus 49, and now we need to multiply by what dx is equal to, 7 secant theta tangent theta d theta. So what I'm going to do in the denominator is I'm going to factor out that 49, so we get secant squared theta minus 1. So first we're going to notice what secant squared of theta minus 1 is equal to, and using the Pythagorean identity, this is actually equal to tangent squared of theta. And now we can go ahead and square the root of both of those in the denominator. So that becomes 7, and that becomes tangent of theta. And then notice here what cancels out. That 7 cancels out, so that's super nice, and also our tangent cancels out. So all we're left with is secant of theta. This we know how to take the antiderivative of, right, or the integral of. We get the natural log of secant of theta plus tangent of theta plus some constant c. But that's not our final solution, right? We're going to go ahead and use our triangle in order to find what secant and tangent is equal to. So here secant is going to be hypotenuse over adjacent, and tangent is going to be opposite, so x squared minus 49 divided by adjacent. And that right there is our final solution. So always make sure if we start with a function of x that we're integrating, we end with a function of x. We're going to try one with definite integrals, and we're also going to try to complete the square. So here what I'm going to do is in the numerator complete the square. So we have the square root, x squared plus 4x minus 5. So what I'm going to do is I'm going to take, in order to complete the square, I'm going to take my middle term. So 4 divided by 2 and square it. And so that is going to be equal to 4. So I'm going to add 4, but I can't just magically add 4. What I need to do is add 0. So I'm also going to subtract 4. Now the purpose of doing this is so I could create a perfect square. So right where I highlighted in blue, that's going to be quantity x plus 2 squared. And then minus 5 minus 4 is going to be minus 9. And then all of this is going to be divided by x plus 2 dx. And notice what I'm going to do right now. I'm going to say u is equal to x plus 2, because I notice I have two of those. I have one in the numerator, one in the denominator. So du is just going to be equal to 1 times dx, or just dx, whatever you like. We also need to change our bounds, which are 1 and 4. And we want to go ahead and figure out what our new u bounds are going to be. And we're going to get that by adding 2. So 1 plus 2 is equal to 3. 4 plus 2 is equal to 6. So let's go ahead and set up our new integral. Here we have the new bounds 3 to 6. And this is where we get u squared minus 9 divided by u times, and that's just going to be du. And so notice here, now we can go ahead and use our normal substitution. So let's go and set that up. We have our a value is going to be 3 because 9 is 3 squared. So we get u is equal to 3 secant of theta, or you can rewrite that as u divided by 3 is equal to secant of theta. So we can go ahead and set up our triangle. Here's our theta, right corner. We have u3, so this has to be u squared minus 9. So we have our u, right? We're able to plug that in. We also need to find our du, so let's go ahead and do that. A lot of people get comfortable just skipping to this step. Du is equal to 3 secant theta, tangent theta, d theta. Or if you wanted to write that as d theta over dx and then multiply it over, whatever you're comfortable with. So we found what our du is equal to, right? And notice here there's one more thing we have to change, which is the bounds. So let's go ahead and set up that chart. I'm going to do it over here. We have our u bounds, which are 3 and 6, and we want to find our new bounds for theta, right? Because we're changing our variable of integration. That means That means we want to change our bounds of integration as well. So here we're going to go ahead and use the fact that theta is going to be equal to inverse secant of u divided by 3, right? So first we get theta is going to be inverse secant of 3 divided by 3, which is 1. So at what angle is secant going to be 1? And that's going to be at 0. So now here we want to find inverse secant of 6 divided by 3, which is equal to 2. I'm going to draw out the triangle for this. I never have them memorized. So 2, 1, that means this has to be square root of 3. So the bigger angle is going to go across from the bigger leg. So that is going to be pi over 3. Okay, lots of moving parts here. Let's go and set up our new integral. So first we're going to change the bounds from 0 to pi over 3. And then we have the square root of u squared. So I'm just going to square it right now. That becomes 9 secant squared of theta minus 9 divided by u, which is going to be 3 secant of theta. And then multiply by our dx, which we found was, du, which is equal to 3 secant theta, tangent theta, d theta. So remember what we did last time. First, we factored out a 9 from that numerator. So 9 times secant squared of theta minus 1. And then we found that secant squared of theta minus 1 is equal to tangent squared of theta. And then our last step is that we can take the square root of both of those. So that becomes just normal 3 times tangent of theta. So let's go ahead and see what cancels out. We notice those 3 cancel out. One of these secants cancel out. So we're left with tangent times 3 times tangent. So let's rewrite that. We have the integral from 0 to pi over 3, and that's going to be 3 tangent squared of theta d theta, which I'm going to go ahead and rewrite. I'm going to bring that scalar multiple to the outside, and I'm going to rewrite that as secant squared of theta minus 1 d theta. So that way we can integrate it very nicely. So we get 3 times, that becomes tangent of theta minus 3 theta, and this is going to be evaluated between 0 and pi over 3. And notice I just already multiplied that 3 in. So let's go ahead and plug in upper minus lower. So tangent of 0 is just going to be 0, so that whole term goes away. So let's go ahead and multiply this out. So pi over 3, that's going to be the bigger angle. So the bigger leg goes across from it. That has to be 1, that has to be 2. So tangent of that is going to be 3 times square root of 3 divided by 1. And that's going to be minus pi, or that could be 3 root 3 minus pi. And that right there is our solution. Let's go ahead and try one more. This is going to be another where we have to rewrite it. So what I'm first going to do is I'm going to factor out a 9 from the square root. So we get x squared minus 1/9 dx. And notice that we can actually take the square root of 9. So the square root of 9 is going to be 3. So I'm going to rewrite that as 3x squared times the square root of that whole thing. So now we can go ahead and set up our substitution. X is equal to a, which is going to be 1/3, right? 1/3 squared is going to be 1/9. Secant of theta, we can go ahead and find dx. So dx is going to be equal to 1/3 secant theta, tangent theta, d theta. And we can also set up our triangle. And notice this is an indefinite integral, so we don't have to do anything with the bounds. And we're going to actually have to use the triangle later to replace back in. And you'll go ahead and see that. So it's going to be x, that's going to be 1/3, and that's going to be the square root of x squared minus 1/9. So let's go ahead and do this thing. So first we have 1 divided by 3 times x squared, and I'm just going to square it right now. So I get 1/9 secant squared theta times the square root, and this is really going to extend out. And that's going to be 1/9 secant squared theta minus 1/9. And of course we get to multiply by dx, which is equal to 1/3 secant theta, tangent theta, d theta. Okay, so let's do what we normally do. I'm going to factor out that value of 1/9, right? So we're left with 1/9 secant squared theta minus 1. Once we start getting comfortable with this, you can start skipping some steps because that is equal to tangent squared of theta. And we can take the square root of both of those. So that's going to be times 1/3 tangent of theta. And now we can see what cancels out. So this 3 can cancel with the 1/3, so we're left with that 1/9. And then let's see, we have one of these secants cancels out in the numerator, and this tangent cancels out as well. So let's go ahead and rewrite this. We have 1 divided by 1/9, that's going to be equal to 9. And then we have this 1/3 right here. And then all we're left with is 1 over secant of theta d theta, which I'm going to go ahead and rewrite this. So we get 3 times the integral of cosine of theta d theta. And that is very nice, right? So here we can take that antiderivative. We get, sine of theta plus some constant c. And then this is where we're going to use our triangle to plug that back in. So sine is going to be opposite. So x squared minus 1/9 divided by the hypotenuse, which is x, plus some constant c. And that right there is our solution. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlist or link down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.